what's going on, clever coders? This is Coding Cleverly with a new video. Today's topic is about STL sets. So what is a set basically? Sets are a type of associative containers. Now there are other associative containers in STL, like a multi-set and maps, but we're going to be talking about those later. Today we're going to be talking about sets. And what they are composed of are just like in mathematics when we deal of a set is known as a collection of distinct elements. So the value of the sets should be unique. They shouldn't be similar, and once you add stuff into it, they're going to be stored into it, and you cannot change them, you cannot modify once they're added, though it is possible you can remove them and add the modified value of the element. This is going to start to make sense once I start writing some code. So let's get started, and what I'm going to do here is I'm going to create a basic set. So the set we're going to create is set and put a data type inside like int, and we just call it as my set. Now this is my set, right? But we could have anything inside of the data type. Over here we can add an additional thing which is called a grader, and the grader could have a data type as well. Now this means that this is gonna be in descending order. Now a set by default is in ascending order, and it's generally with the less type, but you could just relieve this all and don't even have to bother right now, and we're just going to be adding stuff into the set. So empty set, we actually add a container and we put, it's just like we'll just call this as an empty set container. So empty empty set, so container. So this is a empty set container. And right over here, right after that, we want to insert elements into my set. So I could just say inserting elements. How do we insert elements? Now we'll just call my set and we'll just call it an insert method. So the insert method will have inserting elements to it. So let's just insert some numbers. Let's say 20, and then we say my set and insert, and we could just add something else like 40. So now let me just copy this and let me paste here and paste and paste. Let me just change the values up. So let's say this as 80, and let's just say this as 100, say this as 120 something. Okay, so we have numbers, and you can see that I actually did it by default in ascending, but I wanted to let you know that let's have this as something like 10, and this as 4, let's say 35. Okay, so the set is basically going to be sorted in ascending order. You're going to give values to it. So it's going to have it 20, it's going to have 40, it's going to have 35. Okay, it's going to accept it, but it's going to sort it in ascending, so it's going to be 35, 40, and then it's going to be basically 100. So 100 is going to be at the end, and then there's a 10, so 10 is going to be in the front. My set dot insert. If I try to insert something that's already added like 40, it's not going to accept it, all right, because it's unique. So it's just gonna not accept it, and it's just gonna have the same old stuff, so 20, 35, 40, 100. So let's just delete this over here, just gonna delete it, and let's just move on. So nothing's gonna happen, no effect, and let's just print out the contents of our set. So we could just use an iterator to iterate through our set. So how we could do this is basically very simple. If you didn't watch my iterators video, I encourage you to watch that video right away to understand the concept of how iterators work. So we just basically have the set and we put the type into it, and we just actually have anything we want to it. So in this case, for actually defining an iterator, we could just have iterator, and we know that the set by default is not in less, meaning it's in ascending order. So we could just have a colon, and we could have iterator. The name for iterator is ITR, and we just semicolon it at the end. So there you go. Let's just have our iterator defined here. So hash include iterator. And there you go. Now let's go back here and let's just do something else. The iterator is going to be starting out, so we're going to say for, so ITR equals to the beginning of the set. So the set is my set, so we're going to say the beginning of the set, and then we're going to say ITR not equal to the my set and then the end of the set, so we can say end, and we can just say itr plus plus, so plus plus, and then let's just loop through it, so we can just show us the values, which is on the dereferencing operator, and put that right there. So that's going to show us some values, and yeah, so let's run this code. G++ STL underscore set, so there you go, and it compiled, and it has some errors. So first error is set was not declared in the scope. So there's actually an 8. Go back here, and the most important thing that I had to include was the set header file. So hash include set seg. Now hopefully some of the errors will be gone. All of them are gone. So now let's just compile it. So let me just clear this. Now let's just run it. So compile and run. So you can see 10, 20, 35, 40, and 100 sorted in ascending order. Cool. So they're sorted in ascending order. And remember that 40 was neglected. It was already existing, so it just neglected it. How do I sort this in descending order? So by default, I told you that it's in ascending order. And there's an actually there's an additional parameter here, which we didn't specify. So the parameter we had to specify here is basically comma, and we just say less. This tells us that it's in ascending order. Repeat, this tells us it's in ascending order, and it has some kind of type over here. So the type what we explicitly tell is that it's an int, so we just put the int inside of it. And once we recompile this, so compile and then run, it's the same exact thing. But if we want it in descending order, we're just gonna have one exact simple thing is gonna be called as greater. So once we do greater, now it's gonna be sorted in descending order. So just compile it and run it. So now you can see over here 100, 40, 35, 20, and 10. Pretty cool. Okay, so now after this, we know that we could do in ascending, and we know we could do that in descending. How do we do something like removal of stuff? So pretty cool. We could just remove all elements, and I could show you how we could do this. So instead, if we wanted to remove elements from, let's say 10, 20, 30, we want to move this all 10, 20, 35, and we want to move till 40. Remove all of these till 40. How do we do that? Well, there's a pretty easy way to do that, and I'll show you how to do it. So right now, let me just go over here, my set, sorry, and we just have to add something over here, which is called the erase method. And then the erase method will have something which is in the beginning and something at the end. My set dot beginning, my set dot find, and we need to find the value where we want to move till. We want to move till 40, so it's just gonna erase from the beginning, which was I think so 10, and then after that it's 20, 35, and so 20, 35, and now it's gonna find 40, so it's gonna stop there. It's not gonna remove that 40, or it's not gonna remove the 100. So that's how it's just gonna remove this stuff, and you're gonna see 40 and 100 over here. So after removing this operation, let's just look at our thing over here. So let's just look at our set. Just copy this code and just paste it here. Yeah. Going back with the original, which is less, so in ascending order. And now let's just recompile and run it. So I'm just gonna recompile it here. Compiling. Okay, so we have an issue. We have a 28, and there's something here. There's a semicolon. There wasn't supposed to be a semicolon here. Instead, there had to be a comma, which is right here, I think so. So over here, it had to be a comma. Now let's recompile. So recompiling and running. Okay, so then you can see over here we have 10, 20, 35, 40, and then once they were 100, and then once they were deleted, it was just 40 and 100 left. So yeah, that's pretty cool. You could see that it actually did it. It just showed the previous content, and then after that it just erased that portion, and then after that it showed the remaining. Okay, so that's cool. We could remove other stuff. We could erase stuff, and it's so simple. We could just erase a simple element, like I say, my set dot erase, so erase, and just put the element what you want to erase. Let's say 100. I'm just gonna remove the 100 from here, and then you could just do stuff like that. Okay, so now let's try something different. What I'm gonna do here is I'm gonna change this thing up, and I'm gonna create some set and it's going to be by default in ascending order, and it's going to be called my set. What we're going to do is we're going to put stuff inside of it. So let's just put some numbers. Say 10, 20, 30, 40, 50. Okay, so we could just repeat the values again, like 10, 20, 30, and you know it's not going to put it inside of the set, right? Because sets are distinct. They're not unique stuff, and it's just going to ignore it. So it's not going to enter it. It's generally considered that sets are made from a red-black tree. There could be another implementation, but generally, most commonly, it's a red-black tree. From here, we could just have some really simple code. Over here, we could have for. Instead of an iterator, we could just do constant, and I could write auto. And from here, we could just have the address of auto, and we could say E, and we could say my set. And from here, we could just print out the content, or we could just say console output, and we say E, and then end line. Over here, you can see that my set is actually the name of my set, and this constant auto ampersand E, you could just have any kind of name you want. Say element, and that would work as well. So E for element, E, L-E-M-E-N-T. So let me save this, and let's run it. So let me just CLS this screen, and now we're just going to compile it. Okay, so we have some errors here. In line 11, we have some for auto, and then we have a semicolon issue, maybe a semicolon there as well. So let's just go back to our for loop and see what's going on. Actually, it wasn't supposed to have a semicolon here. It's supposed to have a colon. So now let's just recompile this. Sorry about that. And let's run it. So now you can see 10, 20, 30, 40, 50. Awesome. And it didn't repeat that 10, 20, 30, 40. It didn't do anything like that. Suppose we want to have a class over here. So let me just define a class, and I'll call it as pizza. And what we're going to do, we're going to create a pizza class that's going to contain some attributes. Let's say public, and we're going to be selling some pizza here. So let's have a string of the name of the pizza, and let's also have the size, like how many inches of it. So the name of the pizza and the size of it. So we're going to have the size stored in size, like inch size, like 11 inches or whatever. So after that, we want to have our set having this kind of stuff. So how do I make my set do that? Well, I want to change this set to accept my user-defined data type. How do I do that? So I could just have something over here. So let me just comment that out. And I'm going to say set, and I'm going to put my user-defined data type name, which is pizza, inside of this. I'll have less, and inside we could just have the type, which is int or whatever, pizza in here. And then we could have a name, which is called my set. I'll just name it the same exact thing. And what we could do here, we could just have a list initializer to use, and we could just insert the elements which are used inside of this class. So for name, I could just have a pizza name, and let's just name it as, let's say, cheese pizza. Cheese pizza. And the cheese pizza will have a 13-inch size. Just like that, we'll have another, so we're just going to separate it with commas, and we'll say veggie pizza. So veggie pizza, and we're going to have a comma over here. We're going to name the size of the veggie pizza, let's say 9 inches. And then we're going to have another pizza, let's say supreme pizza, 14. Okay, so we have a 14-inch supreme pizza, a veggie pizza for 9 inches, and then we have a cheese pizza in 13 inches. How do I use my set to go through all of this? How do I do that? So in this case, it's not going to work like element. It's going to be working like element, and it's going to have a dot, and it's going to name the name over here, and then it's going to have a space here, and then it's going to say element. Let's have the size here. So name and size should come like cheese pizza, 13-inch. And also, because it's less meaning by ascending order by default, so that means the smallest size should come first, meaning veggie pizza should come first, then the cheese pizza, and then the supreme pizza. So let's see if this works. Now I'm telling you that there is problems in this code. So let's see. just to make sure that there's a whole bunch of problems. And why are these problems occurring? We have an issue that the compiler cannot detect how to compare these values. So we have this object, we have pizza, cheese pizza, we have a veggie pizza. We could compare with the size, so we could apply the size, but it's not actually known, it's not built for the compiler to understand how this is done, because this is actually a user-defined type what we created, pizza. So for that we have to instruct the compiler and do something which is called operator overloading. A video related to this operator overloading, you will see a card on the top right corner. If you didn't watch operator overloading, I encourage you to watch the video to understand the concept, and that concept we're going to be applying in this video. So the operator overloading we're going to be applying, and it's pretty simple. We're going to have a boolean, and it's going to be called an operator. And the thing is, we're going to have the less, because we're going to have to define that it's in ascending order, so it's going to be going with the less sign. So this is going to be the operator, the sign which is less, and now we're going to have to do something really specific here. So inside of this list, let's have a constant and pizza, which is the name of the class. Now constant pizza, and its address referenced, and we could just have it as right hand side. And inside of this right hand side we have a constant. What we need is actually the return of it. So the return, the size is less than the right hand side's dot size. And this is actually gonna understand how this is gonna work. So it's supposed to tell me now that the elements and the attributes are going to be going from smallest to biggest. So let's just recompile this. Let's clear the screen, compile it again. Okay, now we have an error here. We have an error, expected semicolon before class definition in 15. So my class was defined, I forgot a semicolon here. Just hit that. Okay, now recompile it. There you go. There's another issue over here in 26.4. We have a 4 issue. We have a expected comma or semicolon before 4. Let's see, 26. 26 has some issue. Let's see. Has a semicolon issue. Let's see. Okay, I think there's a semicolon issue here at the end. And let me just go back here and compile. Cool. And let's run it now. So A. Awesome. So this is in ascending order. Veggie pizza 9, cheese pizza 13-inch, and supreme pizza 14-inch. So awesome. Now we use operator overloading to do some such thing like that. If we want to have something like in greater, so in descending order, the largest pizza to the smallest, we could have another operator overloading function which is going to define inside the class, and we just put the sign now as greater, and we could just put the same exact thing, so constant, and we could just have pizza, and we could have the address of that pizza, we could have that right hand side. It's pretty much the similar thing, only the sign will actually change. So return, and what we're going to have is the size, and we're going to have it as greater. So we're going to have right hand side dot size, and now inside over there here we have less. We're just going to make this as greater. So this greater will indicate that this is we're actually doing in descending order. So if I run this code now, so let me just CLS the screen when I'm compiling it, and now running it. Awesome. So we have a supreme pizza on the top, 14-inch, then we have cheese pizza 13-inch, and we have veggie pizza 9-inch. Awesome. That was pretty cool. I hope you understood the concept. One other thing that I wanted to mention here, that inside of this we have this pizza defined. We're going to also remove that, and we don't have to have that explicitly defined, and it would still work. So let's just see if that actually applies here. It will still exactly work. Okay, so that was pretty much it with this video. I hope you took a lot from this video. I hope it was beneficial. I hope you learned something new. Tune in for new videos. Hope you subscribe to the channel, and we will see you guys very soon.